operate this thing as well. Okay. So we're going to be using the testnet wallet today. And how you get that running in Sparrow is you go up to the Tools menu, which we have up here at the top, and we say Restart in Testnet, right? And I'm going to do that now. And Sparrow will close and will reopen. And now we are running in Testnet, and it's connected. At the bottom there, you'll see that yellow toggle. That means Sparrow is connected to a server. In other words, it's able to talk to the Bitcoin blockchain. In this case, the testnet blockchain. The great thing about testnet is that the funds don't have any value, which is very helpful for us. So we don't have to worry about losing funds, making a mistake. We can do whatever we want to do. We can, go wild, and nothing has any consequence. And you can practice and then take those lessons to Bitcoin mainnet, which is the network you are familiar with. So I'm going to start by creating a new wallet, and I'm going to call this Adopting Bitcoin 2024, let's say, and I'm going to say Create Wallet. And immediately Sparrow is going to present this screen to me, and this is the Settings tab for your wallet, right? And I'm going to go through each element of this to try and so you understand what each element actually means when you have this. It's not just like people saying do this and this and this, right? So let's start off at the top, right? We have here a drop down which allows us to choose between the type of wallet that we want here, and the type is either a single signature wallet or a multi-signature wallet. As it suggests, that just means when I spend from this wallet, do I need to sign with one signer or do I need to sign with multiple signers, right? If you have multiple signers, it's obviously harder to spend, but that can be a good thing because now it's harder to move the funds. We're not going to create a multiple signature wallet today. We're going to create a single sig wallet. But if we were to create a multiple sig wallet, we'd have to do things like look at how many signers we want out of how many, 2 signers out of 3 signers, for example, all of those kind of details. We also can see that all of our signers appear down here, but I'll get to that in a minute. So the single sig wallet, much simpler device, right? And the first thing that we have to choose is the script type. Now, what is a script type? Well, all of Bitcoin is sent via these locking and unlocking scripts. And we're going to get into that a little bit more when we get into inputs and outputs of a transaction. But a script type really talks to how those scripts work and how Bitcoin is locked and unlocked. And it's very important that we have this ability to lock it, because if we had funds and anybody could spend those funds, we'd be robbed very fast, wouldn't we? So the ability to lock and unlock is critical and core to the entire concept of what we're doing here. So a script type talks to Bitcoin script, which is the kind of process in which we lock, and there are a number of different industry standards, and those we call templates or script types, right? So we have a number of different ones here. In the drop down, we have the old one, which was around 10 years ago, called Legacy. And then we have other ones which have evolved over time. And the most commonly used one is the native SegWit one, which was the default, right? And that's the one we're going to use today. You may have heard of Taproot before. It's not well used yet. So I wouldn't advise using it unless you have a specific need, because there are not as many people transacting in it yet. And that means that your transactions are going to stand out more than on the native SegWit type, right? And the fees are pretty much the same for both. There's a slight difference, but it's not really material. So we're going to choose that. That's the type of script we're going to use to lock and unlock funds. Then we got this descriptor field. Now we haven't actually added any signers yet, so it's still empty. So I'm going to move on past that. We'll fill it in later. And then we go down to the one key store. Remember, we only have one signer in this wallet. So we're only going to be able to add one set of keys, right? And we got these 4 boxes down here below, or rather 4 buttons. And these 4 buttons determine, in Sparrow's case, the kind of signer that we use. So let's look at them one at a time. First, we have the connected hardware wallet. So if you have a Trezor or a Ledger that connects via USB, you have to actually physically plug it into your computer. That would be one of these, right? That's when you would click that button. Then we have the air-gapped hardware wallet. And really the difference between these is that from a cyber security point of view, if you have an air gap, then you have greater security, all other things being equal, right? You don't have a physical wire connecting 2 things together, but you have a much more limited form of communication between 2 different devices. And therefore, it is generally considered that air-gapped devices are more secure than connected ones. That's not to say that connected ones are bad, it's just so that you are aware that there is this difference between them. And if we click on that, we can see there's a whole bunch of them that Sparrow supports. The most commonly used one in this list, just looking through it, people might use a cold card, and they might use it with an SD card. So they'll actually transfer the information backwards and forwards with one of those little SD cards that you put in your phone, right? Or they might use something like the passport, which uses a QR code. So that is, again, a way in which you can sign transactions, but keep the private keys, keep the kind of most confidential information out of Sparrow itself. So even if your Sparrow gets compromised in some way, let's say you didn't verify the download like I suggested earlier, then you can basically take your device and it won't reveal that critical info, right? That's what we're really getting here. So we're not going to do either the connected or the air gap today. We're actually going to create a software wallet. A software wallet, all that means is that the private keys are stored within Sparrow itself. Now you might say, well, that sounds like a really bad thing, but it's actually not. The reality is there's plenty of wealth stored all over the world. If you look at every Lightning node, generally they're using keys that are stored within some kind of software wallet, right? And that's the kind of wallet we're going to create today. I wouldn't necessarily use it to store your life savings in, but as a transactional wallet, there's no real major issue with it. Okay, so it's kind of okay up to a certain limit. And then the fourth box here is the watch-only wallet. That's if you just want to watch funds, and that's where you enter what we call an XPub. We won't do that now, but you'll see what an XPub is in a few minutes. So I'm going to click on that, and we're going to get into these three different options here. We're going to use the first one, which is the commonly known seed words, right? They're also known as BIP39, and that's the standard that defines what this process is. Now what we're actually doing here is taking a very long unique number, right? Think of an incredibly long number and then imagine it much longer than that, because it's actually, this number is so big that our human brains can't even comprehend how large it actually is. And then we're going to reduce that to a set of words, and it's kind of hard for us to grasp how we could reduce such a massively unique thing just to a few words, but it actually does work. The maths works out. And what that means is that we can go around, and the power of Bitcoin, as we know, is that you can just remember a few words and you have access to your funds. So I'm going to create a wallet here with 12 words. I'm going to select the drop down. We're going to have 12 words here. Now because I don't have 12 words, I'm going to ask Sparrow to create those for me. And what Sparrow is going to do is create this really long number. And then it's going to transcribe that into these 12 words. So I'm going to do that right now. I'm going to click the Generate New button, and then I'm going to get these 12 words right here. And now Sparrow is going to ensure that I have written them down. And why is that important? Because if you lose these 12 words, you lose your funds. And of course, you lose a Sparrow wallet file, your funds are gone, right? So Sparrow is here enforcing that everyone is forced to at least once write those words down. If you lose that copy or whatever, there's only so much I can do, right? But it's very important. Don't do what I'm about to do. I'm about to type them out onto a digital document. Don't do that. Write them down with a pen and a piece of paper. Make sure there are no cameras around. Just be aware of the surroundings that you're in. Do it in a private kind of place, because these words are really the key to your entire storage. So I'm just going to put this down for a second so I can type. Yes. If I come up with a word that yes. Yes, that's a great question. Thank you for asking that. It's an excellent question. So don't do that. Don't do what you just said. The reason is that human beings have proven to be very bad at coming up with what we call entropy, in other words, randomness, right? So what you think looks random to you, and is a set of words that you think, well, no one else is ever going to come up with this, the chances that a computer can brute force it are in general, obviously I can't speak to your particular set of words, but in general, much higher, and I'm talking about orders of magnitude higher than what the computer can do. In fact, just yesterday I had a case where somebody came onto the Sparrow wallet group and they had a cold card and they had lost their funds, right? The most scary situation that we're all worried about, right? They logged into Sparrow, one transaction there swept the entire wallet. What happened? What we think happened, we're not sure, is that they used dice rolls on their cold card. So when they set up their cold card, they roll the dice, they enter the number, roll the dice, enter the number, and they didn't do enough dice rolls. And they ended up with what we call a low entropy wallet. And as a result, people were able to brute force the wallet, in other words, guess what the seed words were, and sweep it. That's what we think happened. That's the best. They may have just found the seed words in the guy's drawer. Who knows? But what you don't want to do is rely on human-generated entropy. That is the worst thing you can do, because we humans, as I say, are just very, very bad at it. That's a proven fact. So I wouldn't do it that way. What you should be thinking about, if you really wanted to remember them in your head, and I don't think that's called a brain wallet. It's not a great way to do things, because you may think your brain's good today, but you can't guarantee that it's going to be good in 5 years or 10 years. So I would do it for small amounts, and I'd do it for short periods of time, or sort of either or. But I'd also look into border wallets, which is something that Sparrow supports, which is about remembering a pattern rather than remembering a set of words. So effectively, if you can think of a big grid, and you can basically choose a pattern. In fact, I can actually do it because we haven't written these words down yet. So if I was to show you what the border wallets looks like, it's basically this big grid, and then you choose a certain pattern, right? Say I was able to choose a pattern like so, and the order is important as well. And then this grid, you can imagine, filled with words, right? So if I click the generate button, it's going to create a whole set of seed words here, and then it's going to fill this grid, and then you remember the pattern. It's called border wallets because it's a specific use case for people who need to cross a border. So in other words, a short period of time, because it's not about long-term storage. So I wouldn't do the brain wallet thing for a long period. Does that answer it? Yeah. Cool. All right, let's go back to our set of words, which actually are still there. So I'm just going to put this down and just quickly type these out. As I say, don't do this. Technically, yes, but in practice, it doesn't actually matter. 12 words is enough. People have done the maths, and much more educated in, cryptographic people have done that maths, and they say 12 words is fine. It's not really arguable to say you must use 24 words. Okay. So hopefully I've written those, you've all checked what I've done, and I've written them out right. So I'm now going to go back, and I am going to say confirm backup. Sparrow's going to ask if I've written them down. I'm going to say yes, re-enter the words, and then we're going to be able to create key store. Just before that we do this, I just want to note I haven't used a passphrase here because I don't want to get into too much detail. But a passphrase is like an additional word that you have to remember. So Sparrow's not going to remember that word for you. It's very, very highly misunderstood. So people confuse the word passphrase with password. There's all kinds of issues that come in there, to the extent that Sparrow now puts up a big warning if you want to use a passphrase and says this is an advanced feature. So I'm not saying don't use it. I'm saying be aware that we are then back in the world of this gentleman's thing where, so in your case, you would maybe use a long passphrase, which would be something that you have to recall. I would still advise that you write that down at some point, because human memory is a lot poorer than you might think. It really is. And if you don't write it down, practice it. Go and, if you share it with your wife or what, have you practice it. Have some means of being able to recollect that word, because without that practice, I guarantee you it will become fuzzier in your mind. Or at least if you enter it all the time, then obviously you will have that practice as well. No, so the passphrase just gets added to these set of words. You can think of it as a 13th word. It's effectively all that it is, right? And it's just one that Sparrow doesn't store. So that's the difference. Sparrow will store these 12, but it'll ask you for the 13. And if you don't remember it, your funds are gone. You'll never fund them again. If you literally cannot remember that, they're gone forever. So it is a serious thing to add, and that's why I call it an advanced feature.
Did you just copy and paste those 12 words from the notepad?
Yes.
And they automatically went?
Yes.
That seems like a feature you shouldn't have.
The feature that you shouldn't be doing is writing them down on a digital copy. That's what you shouldn't be doing. Yeah, otherwise I'd have to sit here and transcribe back and forth. So it's just a bit, it just makes my life, I have to test this wallet and I have to do this kind of thing often, so it makes my life easier. Exactly. Privileged access here. Okay, I'm going to go ahead and create the key store and store now, and I just want to show you that there is this field below here called the derivation path. I'm not going to go into it now, we're just about to, but you can change it here. I just wanted to highlight that fact before we move on. I've now imported the key store. So what I've done is I've taken those 12 words and I've imported them into Sparrow, and now we have the set of fields. Instead of those 4 boxes, we now have the set of fields here. Let's go through those fields, actually 5, one by one. First of all, we have the type. It is a software wallet, and if I click on the view seed, we'll see again those 12 words, right? So we know that this key store, the signer, represents those 12 words. We then have a label. And then we have something called the master fingerprint. And what is that? That is taking those 12 words, converting it back into that very long number, and then deriving what we call a private key. And that private key is called the master private key. And that is the key kind of piece of information around all of the information in this wallet is going to be derived, the master private key. It's also called the XPriv. Like we have an XPub, it's called an XPriv. And then what we do is from that private key, we can derive a public key. And that's the whole Bitcoin works, right? It has this kind of system of private and public keys. And this is the first 4 bytes of that public key. Now, what that practically means is it is a unique identifier for those 12 words. That's what this actually is. And this little image here on the side, this sort of reddish image, is an algorithm that creates a unique image for those 4 bytes. In other words, this little image here makes it really easy to see. Now, if we had used a passphrase, Sparrow would show us this image as we typed our passphrase in and as we changed our seed. So as we were typing it in, we could get to the end of our passphrase and check and say, oh yes, this is the kind of maroon colored box, and we know we've got the right passphrase, right? So it's a little visual reminder that you are in the wallet that you expect to be in. No, you don't. You can always get it so long as you have the seed words. Okay, so it is derived from it, but it is a key part of this wallet in the sense that it identifies this particular seed. Now we have the derivation path, right? And I want you to focus here, because this is actually, if you understand this, it really explains how these wallets work. So the derivation path is basically very much like the folders on your hard drive. So you can nest one within the other, okay? And this works in the same way. So you have these different segments, each of which is separated here by a slash. And the first one here is the M. Now the M stands for the master, right? It's the top one. That's the one that I just said, the master private key, right? That's the one that starts off at the top. It's like if you had a Windows machine, it would be like your C drive, right? The root. Then we have the 84. That's the one level down. Now standards say that if we have a native SegWit script type wallet, again going back up to the top here, then we use the number 84. And if we had a different script type, we would use a different number. And why do we do that? We do that so that if we use a different script type, we generate different keys, because this derivation path is going to be applied to that master private key to create addresses at the end of the day. It's going to create keys and create addresses from those keys. And what we want in this situation is be able to reuse our seed if we want to, and not reuse the same keys. So even if we have a different script type, we can reuse the seed many times over with we can create a taproot wallet, same seed. We don't have to go and create a new set of, we don't have to go and bang a new steel plate. We can create a taproot wallet off the same set of words, and we'll have different keys. Why? Because the derivation path enforces it. The next step on this thing is the number 1. Now here I have to say that all programmers use zero-based indexes, so that's an important thing to remember. So the number 1 is actually 0. You have to remember that. So when we're talking about a 1 here, we're actually talking about the second number in this range. And that number 1 refers to the testnet network, which we are using here today. If we were on mainnet, again, the network everyone's familiar with, that would be a 0. But here, today, it's a 1. And then the final one is titled account. An account is really like it sounds, right? If you have a savings account or a check account, if you have an account for saving up for a vacation or whatever, it's just an account. It has no meaning beyond that. In this case, we have the number 0. In other words, it's the first account. We could create multiple accounts here. And next one will be 1 and 2 and so forth. It doesn't really mean anything more than its own little area, but it allows us to, off the same seed, create wallets with different purposes.
And you can send funds between different accounts.
That's correct, yes. So it's really, as I say, the idea of a hard drive with different places you can put files is kind of similar. It's this path which we use in order to derive things from the master seed.
Do different accounts use the same expert?
No, they don't. Well, we're about to get to that, so that's a good question. So what the final field here is taking that derivation path and then taking the seed, right, taking the master private key, which is very closely linked to the seed, and then deriving the key at that particular derivation path, right? That's what we are doing here. And this XPub describes basically all of the public data for the keys at this level, right? And that allows us to then derive the entire wallet from this particular thing. Now, here it's called a TPub because we're actually on the testnet network, and that's what we call it there. But the TPub and the XPub, the same thing, it's just different names. So if you take, again, the seed, you take the derivation path, you're going to end up with the XPub, or in this case, the TPub. Okay, so that's what Sparrow has done. And when you see an XPub, that's actually what it is. There's somewhere behind it a seed. There's somewhere behind it a derivation path. Even if it's just a one-level path, it's still there. And that has derived that particular XPub at that level. Okay. So that was like an older standard there where you would have a script type would kind of have its information inside there. So like a ZPub was a native SegWit wallet. We're kind of starting to move away from that now. It doesn't exist, for example, for Taproot wallets because people realize that it's a bad idea from an engineering perspective to kind of push these two things into one. But older wallets, many wallets, still use the idea of YPubs and ZPubs. It just means that there's a suggestion that you should use a particular script pub with this, script type with this XPub. Okay, so I'm going to go ahead and save this wallet now by clicking the apply button. I'm going to give it.
I have a quick question.
Go for it.
This XPub is specific to the account, meaning that yes, if I give this to someone, they can derive all addresses, but they wouldn't derive addresses of account 1 then, right?
Yes, correct. That is right. That is right. I could go into the details, but I won't today of why that is the case. But yes, that is correct. It's also, I wasn't kind of brushing over the fact of this kind of private and public keys because that can get into some detail here. But the whole concept around which Bitcoin works is that it's very easy for us to take a private key and derive a public key, but very, very, very hard to go back. And that's kind of the key kind of cryptographic premise on which all of Bitcoin and in fact much of all of the sort of cybersecurity we have in the world is actually based on. All right, so let me go ahead and set this password, save the wallet. All right, and what happens now is that all of these boxes here become blue, which means that we now have a valid wallet. And Sparrow has already gone off to the blockchain and said, are there any funds? Let's go and check to see if we have any transactions. And of course we don't, right? We just created a completely new seed, which means we don't have any transactions on it. So what are we going to do? We're going to obviously pull some funds into this wallet so we can do something, right? And here I'm going to try and do it the way that I used to do it, which was to use a faucet. But before I get there, I want to explain a little bit more about what we actually have here with this wallet. So in order to get funds into this wallet, we're going to need an address. So I'm going to go down and click on addresses. And immediately we are shown these two lists. And what are these two lists here? Well, one is the top. It's the receive addresses, and it represents the external addresses for this wallet. And the second list is the change, and it represents the internal ones. Now, why do we have this difference? Well, if we were to give, say, this first address here, and it ends with SANS, right? And we were to give this to somebody out there, and then they were to, at some point in the future, send funds to this wallet. But then we also had a situation where this wallet needed to send funds back to itself, right? And we'll go into a bit more detail about why transactions work in the way that they work. We might end up with a situation of address reuse, where this wallet was sending funds to an address that it thought it wasn't used, and then somebody in the future also sent funds to it, right? And that's not a good thing. We don't want to have addresses reused. So what we want to do is to be able to have a set of addresses that this wallet knows it can send to and nobody else has any knowledge of them, and then a set of addresses that the wallet user can give out to others. That's the reason for these two different lists. So let's go and take a look. So we obviously want a receive address, an address we're going to supply to an external party in order to receive funds into this wallet, and that address is obviously going to be the first one here. So we're going to go across here, and there it is. It's that address that ends with SANS, right? Now I just want to draw your eye down a little bit to the derivation path, because this is really where, for me, the sort of magic of it actually comes in. So we see here that we have this path starting with the first three elements that we saw previously, right? The 84, the 1, and the 0. So that is all things that we've seen before. But then there's two parts at the end, the /0/0. Now we have, again, the 0-based index. So these are the first ones. And the first one of this, the first /0, refers to the first list that we just saw, the receive addresses. And if we had the /1, we would be referring to the change ones, right? So it's just those two. It's /0 and /1. You never really see that number differing at that level. And then finally, we have a /0 at the end, and that just refers to the first address in the receive list. So if I go back to the addresses here, and I hover over these, you're going to see ... in other words, all of your 8410, and then it says, /0/0. And if I was to move down to this one, it says /0/1. Now, if I was to drop down here, you'd see /1/0. In other words, we're looking at a different set of addresses, and if I was, it would be /1/1, /1/2, and so forth. And that's how the wallet generates all of the addresses that it ever has, right? It's just increments numbers in order to create different addresses for different uses. And behind every address is a key, and that's the key that is actually being used in order to identify the funds, and that's the key that we then sign against, right? This is the public key, and we'll be using the private key connected to this when we actually sign a transaction. So that's, in a sense, if you can grasp all of that, you understand how a Bitcoin wallet works. All right, here comes... No, not from the outside. Only within this wallet can you see it. And that's very useful. In fact, any address derived at any derivation path from the outside looks exactly like any other.
And if you give someone a change address, they can still send it.
Correct. It works just as it's purely a wallet defined thing. It's not a Bitcoin defined thing. It's like, from Bitcoin's point of view, it doesn't care at all. All right, so I'm going to now try and hopefully receive funds to this wallet. As I say, this is the tricky part because I'm now using a Bitcoin testnet faucet. So there are sites out there that will send you Bitcoin for free. It sounds crazy, but obviously this Bitcoin doesn't have any value to it. Oh, excellent. Well, let's give this a try. It might work. Who knows? I'm going to paste that address in, that SANS, and let's see if it works. Okay, stairs. This is it. Tricky business. I think that's stairs. Okay, let me try again. Oh, no. Motorcycles. It's one of these hard ones too. They're kind of in more than one frame. We wait in anticipation. Okay, that looks good. That looks good. Success, success. All right, so now hopefully we should start seeing some funds in here, and there they are, right? So that testnet faucet just sent us some funds, and we will now be able to transact in this wallet. Very exciting. Now, what has actually happened here? Well, what has happened is that the faucet has created a transaction to send money to that address. And what that money actually is in the form of an output. And this is where we're going to start getting into Bitcoin transactions and what they actually mean. And every transaction has a series of inputs which reference previous outputs and then its own outputs. And I'm going to show you what that looks like in a diagram in a minute. But just to kind of get into it, we're going to go down to the UTXOs tab. And UTXOs stands for an unspent transaction output. In other words, this is a transaction output that hasn't been spent yet, right? They've just sent it to us. And that transaction output, which we see here, it's to the value of 194,977 sats. And it is to that address that we pasted in earlier. And this represents an output that we are able to spend, right? We are able to reference this output in a transaction if we wanted to send funds. So let's go ahead and do that, right? Let's go and send some funds. And what I'm going to do is just click on send here. And we're now going to move into this area of the wallet. Now what I'm going to do is send funds to myself. So what I'm going to do is go down to the addresses tab, and we're going to have a look and see, okay, that's the second address in the wallet. And in fact, if I click on the receive tab, you'll see that the same address appears here. Why is that? Why do we get the same address that we had before? Anyone want to explain it? Correct. We don't want to reuse the same address. So Sparrow will always suggest an unused address, right? That is a very important part of it.
When the UTXO, when he sent the UTXO to you, are they now in limbo somewhere? They don't belong to him, they don't belong to you.
That's a great question. So they are in a sense in limbo, but they're actually not, right? So until that transaction has been confirmed on the blockchain, they would still, it actually didn't come from Cole, it came from some other service. But the point is that they belong to that wallet still until that transfer of ownership has been confirmed. And that confirmation is really these days the first time that you actually see it committed onto the blockchain itself, right? But if you want to be really secure, then you kind of want to, for 6 blocks later, to have passed, and then you know, well, there's no chance of us rolling back, right? But at this stage, it is money that would be very hard for them to retrieve, but technically it still belongs to them, right? So if, for example, the fees shot up massively and this particular transaction never got confirmed, which it just did, then you would be in a situation where like that transaction never happened. Yeah. Yeah, it doesn't actually go back to, it just never actually leaves his wallet because it was never actually confirmed.
While it's still in a mempool, not being confirmed, can you spend it?
Yes, you can. Yes, yes, you can.
Also respend it with a higher fee if it's replaced by a fee.
Yes. So yeah, so you're in this kind of slightly limbo such a situation where somebody can come along and replace that transaction and spend it to someone else. Obviously, though, they have to have control over the private key, otherwise they can't create a transaction that will replace that one. But that's kind of getting into the weeds of it. I'm going to go back to the send tab now. I'm actually going to copy this address here. I'm going to click send, and we're going to paste it in. And then I'm just going to give this a title of test. And we're going to send an amount. I'm just going to say send 1,000 sats, right? So let me just click that there. Okay. So what we're doing here is, and I'm going to open up this transaction diagram so you get a sense of what this transaction that I'm creating actually is doing. I'm referencing that unspent output that was sent to me earlier, right? You see that the value here is the same, and that via this transaction. This is called a transaction input, and a transaction input references an unspent output. That's what it's doing, right? And then this transaction then spends the 1,000 sats that I entered earlier, right? And then it sends change back to me. Now, why is it doing all of this? The key concept around how Bitcoin works is that every time you spend a transaction output, you consume it fully. You don't reduce its value. It goes from the value that it has, 194, down to completely spent, down to effectively zero in terms of its spendable value. And that means that if we don't want to spend the entire thing, we want to send it all to someone else, we have to send change back to ourselves. In other words, we have to split that value. As you see in this diagram, that value is now being split. The 1,000, which we're sending to this address here, and the remainder sending to a different one. What is the address we sent to? Well, if you look at the little tooltip here, you can see that we're sending it to /1/0. And what is that? A change address, right? So we're sending change to that list of change addresses, and this is the first change address that we had. Now, hopefully what I said about the external and the internal addresses makes more sense, because Sparrow needs to be able to know at any time that it can get an address which no one else is going to use, right? So that's why it uses the set of change addresses, and that's why they exist in your wallet, so that no one else from the outside is going to send to the same place. And then finally, we have the fee. Now, the fee looks like an output here. It's actually not. This is a value flow diagram. So the fee here is basically an amount that we need to pay the Bitcoin miners in order to include our transaction in the blockchain. And luckily on testnet, the fees are never high. You never have to worry too much about the fees. So we're only paying 141 sats for this, but it does have to be part of it. And what's actually going on here is this is not an output. This is implicitly included. So if we were to take that amount there and that amount there and subtract from this amount here, we would have this difference. So a fee is the difference between the inputs, the referenced outputs that the inputs reference, and the outputs that we have created. Now, you could ask, well, what would happen if I didn't include a fee? What would happen if this amount and these two amounts added up to be the same? Well, the reality is that our transaction would never get mined. In fact, our node wouldn't even take it. They wouldn't even accept it. There's a minimum transaction fee. In other words, there always has to be a difference between the inputs and the outputs. Otherwise, your transaction is simply not going to happen, right? And the more you spend on that difference, the more likely your transaction is to be included in the chain. So when we talk about high fee rates, we're talking about a greater difference between the inputs and the outputs. Technically, that's what it actually means.
So I just want to understand, so the fee is not explicitly stated. It's
Correct.
calculated by the miners based on the difference.
Correct. That is it.
And when a miner orders a transaction, I assume it's on the total fee, not on the sats per V.
No, actually, all of what miners do is they look at the fee rate, right? So, yes, so they actually look at the size of the transaction in bytes, and then they say, well, how much fee is being paid for how many bytes, and they will mine the ones with the highest fee rate first. But we'll get more into that as we go and sign. I just want to see how much time I have left. I think I'm actually running out of time, to be honest. But let's finish this, right? So I'm going to go ahead, I'm going to create. This opens up a different tab, which is much the same diagram that we had in the past. We see our inputs and our outputs here on the side, and it gives us a bit of information about what we're actually doing. We are doing a consolidation because we're sending back to ourselves, and it gives us the address that we are sending to. So we can click here, finalize, because we're happy with the transaction that we're doing, and now we can click sign. Now I just want to go through these blocks here. We have a way here at the bottom to interact with different kinds of hardware wallets. So if we had an air-gapped hardware wallet like a passport, for example, we would show the QR, which is this, right? And we could then scan that with our air-gapped hardware wallet, and then we could scan after signing on the device. We could then scan, and we could use QR codes to convey the signatures back and forth between the hardware wallet, which has the private key, and Sparrow. If we were using, for example, an air-gapped cold card, we could save this transaction, put it onto an SD card, shuttle it back and forth, and bring the signature in that way. But today, obviously, we have a hot wallet, so I'm just going to click on the sign button here, and I'm going to enter the password, and it's then going to basically decrypt the private key, which is held in an encrypted form in Sparrow otherwise, and then it's going to sign, right? And that's what this blue bar that you see here in the middle is. Basically, the signature has now been added. First of all, I'm going to click on View Final Transaction because, to Rob's earlier question, this kind of colorful box down here at the bottom, these are, in terms of hex, the actual bytes that are included in the blockchain forever, right? These are the actual ones that will forever be there so long as our transaction gets mined. And you can go through this. The one little part that I want to show you is this little field here. It usually starts with 3 or 4. That's the signature that was created, right? So that when we sign, this is actually the thing that unlocks the funds, right? So I just show it because I think it's useful to see what are we actually doing. We are creating this little thing here, and we are sending that out to the miners and saying, hey, we've paid you a fee. Will you please include this in the blockchain? And that's actually what's going on. This is what the whole process of Bitcoin sending funds between each other is, exchanging these little bits of information and getting these included on the blockchain. So I'm going to go ahead and do that. I'm going to broadcast this info, and we are now hopefully going to see, there we go, this transaction. And the reason that it has this value of minus 141 bytes, right? Why does it have that value? It's because that's the value we spent to the miners. This value shows us the change in value to our wallet. And all that we did, because we sent back to ourselves, is we just spent some money and gave the sort of miners their fee, which is why the balance of this wallet has reduced by that amount there. So I think I'm actually out of time. Can anyone verify?
Yeah.
I am. So yeah, that's really, I hope that that's been helpful for you to try and understand how Bitcoin wallets work, because that's the kind of detail. And once you understand that, there's no magic behind it. It's just deriving keys, it's signing against those keys, and it's locking and unlocking funds based on that. That's it.